Morning students. In this video we are going to see what is a prime number and prove that there are infinite number of prime numbers. So before going to the content, we start with the definition of prime number. A number which is divisible by 1 and itself is called prime number. So take the number 3, it is divisible by 1 and 3. Take a number 5, it is divisible by 1 and 5. Similarly 7, 1 and 7, divisible by 1 and 7. 9 is not a prime number because it is divisible by 3. And then we have 11, 11 is divisible by 1 and. So these are the prime numbers. A number which is not a prime number is called a composite number. A number which is not a prime number is called a composite number. Namely, examples of composite number are 4, 6, 8, 9, 12. 4 is divisible by 1, 2 and 4. 6 is divisible by 1, 2, 3 and 6. 8 is divisible by 1, 2, 4 and 8. 12 is divisible by 2, 3, 4, 6 and 12. So these are non-prime numbers, that is composite numbers. To prove there are infinite number of prime numbers, this is the result we are going to prove. To prove this result, we need this result, that is, any non-prime number is divisible by at least one prime number. Take any non-prime number and we can prove that, or we can say that it is divisible by at least one prime number. I have given some example. Take a non-prime number 12 and it is divisible by a prime number 3. Similarly, if you take a non-prime number 15, this non-prime number is divisible by a prime number 3 and 5. So every non-prime number is divisible by at least one prime number. This is the important result which we are going to use to prove there are infinite number of prime numbers. Suppose capital P is the largest prime number. Assume that. In recent days they have published the largest prime number using some computers and language. They are proving that this is the largest one. But we cannot say this is the this is the largest prime. So there are infinite number of prime numbers. So assume that capital P be a largest prime number. Let it be capital P. Now using this number, I am going to construct another number capital Q, which is a product of these prime numbers, that is 2, 3, 5, 7, 11, 13, 17, etc. etc. and largest prime number capital P plus 1. These are in product 2, 3, 4, 2, 3, 5, 7, etc. etc. up to P in product plus 1 number. We are going to prove that capital Q is also a prime number. Then definitely this is a number greater than P, and hence the result follows. So this is the idea we are going to use in this method. Clearly, the number which we have constructed, that is Q equal to 2, 3, 5, 7, 11, etc. etc. up to P plus 1 is not divisible by 3, 2, 3, 5, 7, 11, 13 and P, as it has remainder 1 when divided by this number. If you divide Q by 2, you will get a remainder 1. If you divide by 3, you will get a remainder 1. If you divide by 5, you will get 1. Similarly, if you divide Q by P, you will get remainder. So the Q is not divisible by 2, 3, 5, 7, etc. etc. up to P. Suppose we assume that Q is not prime. We know that every number is divisible by itself, and suppose Q is not prime, then it is divisible by itself because of the result. Every non-prime number is divisible by at least one prime. Already these primes 2, 3, 5, 7, etc. are not the device not divisible, that is P is not divisible, Q is not divisible by these numbers. And we know the result that every non-prime number is divisible by at least one prime number. So suppose Q is not prime, then it is divisible by itself. That is Q is divisible by itself. This shows that Q is a prime number other than, greater than P. So there are infinite number of primes. This is the result explained by G.D. Hardy in his book Mathematician Apology. In this book, we have some other results also, that is Fermat's two squares theorem. That is any prime number in the form P equal to 4n plus 1, then that prime number is expressed as sum of the squares of two integers. So using this idea and Fermat's, will get some light on prime numbers, and there are infinite number of prime numbers. Thank you.